Hey everybody, Dr. O here, and today I want to talk about glycolysis and fermentation. So let's start off talking about glycolysis. And we know that with glycolysis, we're going to take a glucose molecule, which is a 6-carbon molecule, and we're going to break it down and convert it into two 3-carbon molecules that we call pyruvate. Now, glucose is not our only input. We know that we have to put in a couple of ATP to get this process started, but we know that we're going to end up with 4 ATP on the products side of thing, but we don't gain 4. We only gain 2 because it took 2 to get things going. So that's a little bit about ATP. But what we're not telling you is information that is contained in this blue arrow. The steps that are involved to get from a 6-carbon molecule to 2 3-carbon molecules. And as a result, we have to have something that is capable of kind of stepping in and helping to take care of some of the cast-offs, if you will. And that's going to be where these two ions of NAD show up. So what has to happen in order to get from a 6-carbon molecule to 2 3-carbon molecules is that we have to eliminate a couple of hydrogens in the process. And so NAD ions show up and they're capable of taking on those hydrogens, and in this process we create NADH molecules. And we love that because we know that those molecules are going to become very beneficial at the electron transport chain. But when we're talking about glycolysis, the thing that everybody likes to celebrate is this portion up here. But what about these NAD molecules? What's their story? Well, let's talk about that. So what do we call this molecule? Because it does have a name, a rather long one. It's called nicotinamide adenine dinucleotide. Now you'll notice in the last word, nucleotide, hopefully that's ringing a bell about a particular shape of a molecule, because the thing we know about nucleotides is that they have a 5-sided sugar ring, and they have a phosphate, and then they have some sort of nitrogenous base. If we're talking about a nucleotide involved with making DNA, that nitrogenous base is going to be the ATCG business. If we're talking about a nucleotide making up RNA, it's the AUCG business. Okay, so let's bring up a picture of each one of these. So there's our ion off to the left and our molecule to the right. And I'm going to point out right down here, there's a nucleotide, there's our sugar, there's our phosphate, and there's our nitrogenous base. Now, where have we seen adenosine before? That's on ATP. Adenosine triphosphate. Essentially, ATP is a nucleotide with a couple of extra phosphates added. This is also a nucleotide, because this molecule right here is also a nitrogenous base. But you might know it as vitamin B3 or niacin. So you might have remembered in a lecture about coenzymes or cofactors that it was always mentioned that minerals and vitamins can actually end up playing a role. Well, here we go. There's B3 right here, because that is one of the roles of this molecule. It does act to catalyze reactions, and in fact that's what we saw it do in the glycolysis reaction. Without the presence of NAD ion to accept the hydrogen that gets cast off in glycolysis, the reaction wouldn't be able to move forward. This molecule also plays a role in driving enzymatic reactions in a lot of other metabolic pathways. So this is a very important molecule in the body. The thing about this molecule is that we only have so much. So we have to be rather judicious in our usage of it and ensure that we are making speedy reactions and making the correct version of this molecule available for the correct metabolic pathway. All right, so that's enough about that. Let's talk about this molecule and its role in fermentation. When it comes to fermentation, there are two processes that are going to give us two different products. One product is going to give us alcohol and the other one is going to give us lactate. We're going to start off by talking about alcoholic fermentation. The process is going to give us alcohol as our product. Now, in order to talk about fermentation, either process, we need to have already done glycolysis because we start fermentation with 2 molecules of pyruvate. Now, through the magic of our blue arrow, we're going to turn pyruvate into a couple of molecules of acetaldehyde or acetaldehyde. And the thing that I'm going to point out is that our pyruvates have 3 carbons and our acetaldehydes have 2 carbons. So you might be wondering, well, where did this carbon from pyruvate go and where did it go from this pyruvate? Well, we released those 2 carbon molecules in the form of carbon dioxide, 2 molecules of it, and that is why often alcoholic fermentation produces gas, because we're eliminating one of those carbons in this first part. Now you might be asking yourself, are we done? Well, no, because acetaldehyde is not alcohol. We have to convert that into our alcohol molecules. So we're going to do that right now through our blue arrow. So we've taken our 2 molecules of acetaldehyde and turned it into 2 molecules of ethanol. Now I'll point out that we took one 2-carbon molecule and turned it into a different 2-carbon molecule. Now how do we do that? Because we don't see any inputs here, at least not yet. Well, in order to do that, we have to bring forth a couple of our NADH molecules. And what I'm going to say next is not exactly correct, but I'm going to say it this way because it kind of looks like this. But our NADHs are going to cast off their hydrogens and add them to the process and help convert acetaldehyde into ethanol. And as a result, it's going to leave us with 2 ions of NAD. Now, when we were on a screen like this talking about glycolysis, the thing that we celebrated was this reaction right up here. And we were so happy that we created a couple of pyruvates and 4 ATP. But on this screen, we haven't created any ATP and we haven't created any pyruvate. We've created a couple of molecules of alcohol. I guess we could celebrate that. But the purposes of this discussion, we want to understand why this is an important process. And fermentation is an important process because of this right here, and specifically these 2 ions that got created. Because these 2 ions of NAD can be fed back into the system and fuel another glycolysis reaction. Because remember, glycolysis will take NAD and convert it into NADH. So that is the beauty of fermentation. It makes available a couple of molecules of NAD to be converted into NADH, which is necessary to catalyze glycolysis. Now, in this process that we're looking at on the screen, alcoholic fermentation, we need to ask ourselves, who is the electron acceptor in this process? And it's going to be these 2 characters right here, acetaldehyde. Let's have a look at lactic acid fermentation. Now, like alcoholic fermentation, lactic acid fermentation requires that we've already done glycolysis because we're going to start off with a couple of molecules of pyruvate. And we're going to convert those into lactate. And I'll point out here that we are basically taking one 3-carbon molecule and converting it into a different 3-carbon molecule. So we're not releasing gas in this process. But in order to convert from one 3-carbon molecule, pyruvate, into another 3-carbon molecule, lactate, we have to have an input. And that's where our buddies NADH show up. And just like in alcoholic fermentation, we're going to see the same sort of conversion of NADH into the ions of NAD. So we can kind of think of that hydrogen being added to the mix in order to create lactate from pyruvate. And this, again, the same reason why this is a big deal is not because we love lactate, but it really has to do with what's happening down here, and specifically the creation of these 2 ions, which can be fed back into the glycolysis and drive another glycolysis reaction forward, which creates ATP and pyruvate, which help fuel this reaction. Now keep in mind, we're not likely to have lactic acid fermentation as long as we have the availability of oxygen. because we get far more ATP produced through aerobic processes than we do through anaerobic processes. And glycolysis and fermentation are both anaerobic processes. But hey, if you're not in good condition and this is the only thing you have available to you, your body's going to use it. And in that way, we got to love the fact that we do have this process available to us when conditions are less than optimal. Oh yes, and before we leave, we have to ask who in this scenario is going to be the electron acceptor. Well, in this case, it's going to be pyruvate. And with that, we are done. Thanks for watching.